From various locations in Latin America, billions of dollars worth of marijuana and cocaine enter the U.S. each year. Their boats loaded with contraband, smugglers cross the Caribbean and navigate northward through various passages on their way toward landfall in the U.S. Previously, the odds of going undetected favored the smuggler. After all, the ocean was vast, the smugglers were numerous, and with a limited number of Coast Guard vessels available to conduct maritime searches, the probability of a Coast Guard smuggler encounter on the high seas was relatively small. Now, shifting the odds and increasing the smuggler's risk, there's a new dimension in sea surveillance, an innovative Coast Guard program called MIST, Maritime Interdiction and Surveillance Team. This program encompasses 3 elements: detection, identification, and interception, and has the mission to increase the rate of interdiction of drug traffickers. From an operations center on board a Coast Guard cutter, the MIST commander utilizes the assets at his disposal: a sea-based aerostat, the detection element; helicopters, the identification element; and a cutter or patrol boat, the interdiction element. The sea-based aerostat, a key element of the program, is a product of TCOM Corporation. Equipped with a Lytton radar, it provides the MIST commander with an efficient and cost-effective wide-area detection system. Now, life can never be quite the same for the smuggler. With 24-hour-a-day surveillance, the aerostat can detect all targets within its coverage area, monitor their movements, and establish target tracks, even in rough weather conditions. The aerostat consists of a helium-inflated hull, 3 stabilizing fins, and a windscreen. It's constructed of a Dacron and Tedlar lightweight and maintenance-free fabric. Designed for cost-effectiveness and simplicity of operation, it requires only 3 crew members and less than 15 minutes for in-hauling from its operational altitude of 2,500 feet. Located within the windscreen is a sea surveillance radar manufactured by Lytton Systems. The radar's gimbal-mounted antenna rotates 360 degrees, providing reliable tracking of targets. While at its operational altitude of 2,500 feet, the radar range of 70 miles gives coverage over an area of more than 15,000 square miles. The stable, vibration-free platform provided by the aerostat increases the radar's mean time between failures when compared to aircraft applications. And with a larger antenna than can be mounted on an aircraft, detection performance is increased even more. With this continuous radar coverage, the smuggler is detected and tracked as he enters the surveillance zone and continues northward toward his clandestine rendezvous. A typical vessel used for shipboard aerostat radar systems is 194 feet long and has a maximum speed of 12 knots. The vessels are of the type used for the supply of offshore oil drilling and production platforms and have ample fuel, crew, and cargo facilities. When the aerostat is in flight, the catenary of the tether has the effect of completely insulating the ship's motion from aerostat motion. The aerostat is not affected by the motion of the ship, nor is the ship affected by the aerostat. When the aerostat is retrieved, it is attached to a pivoting mooring system which is mounted on a gantry. In the moored position, the gantry is at the ship's stern, permitting the aerostat to weather vane 360 degrees in response to changing wind conditions. Steel rails welded to the main deck allow the gantry to move, so that during flight operations, the gantry is positioned just aft of the superstructure for better ship's handling characteristics. The aerostat is tethered to the vessel by a high-strength cable with a multi-function core which sends electrical power up to the radar by means of metallic conductors and relays radar target data down to the vessel through fiber optics. Made from strong, high-tech, lightweight fabric which requires no rigid frame, the aerostat is virtually maintenance-free. In less than 15 minutes, 3 crew members can launch it from ship moorage, to full operational altitude. Operating at 2,500 feet, the aerostat has an on-station time of up to 10 days. After 10 days, it is normally recovered for inspection and helium replenishment. The aerostat is equipped with a metallic lightning protection cage, which shields crew members and the aerostat itself from any lightning strikes. Meanwhile, with his illicit cargo, the smuggler continues through one of the natural Caribbean choke points on his journey to the U.S. Target information is displayed on a monitor in the operations center, located in a customized container just aft of the vessel's pilot house. The operations center is also equipped with a computer system which tracks the target's movement within the coverage range of the aerostat radar. On board the command vessel, the MIST commander has an identical computer system which displays the same target information. In this particular instance, the MIST commander is informed of a new target, the suspected smuggler. In turn, the commander orders a helicopter into action to make positive identification. The smuggler has no hint of it, but his time is running out. Receiving confirmation of the fishing boat's identification as a suspected target, the MIST commander updates himself on the position of his intercept assets. Immediately, the computer displays the location of the cutter nearest the fishing boat and provides a course for target intercept. The commander gives the order, and a Coast Guard vessel proceeds toward the target. This real-time tactical information is a crucial asset to the MIST commander, significantly aiding in mission accomplishment. Especially designed for this new dimension of sea surveillance, advanced software for the MIST program was conceived and written by the Coast Guard Research and Development Center. The MIST commander, with his powerful eye in the sky, detects the target, analyzes movements, and tracks the target. Using his helicopter, identifies the suspect, and with his cutter, intercepts the target. Then, with clockwork-like efficiency, the smuggler is apprehended and the mission is accomplished. A comparison of different methods of surveillance shows a variance in capabilities and cost. Aircraft surveillance is a brief look system. Once the aircraft passes, the target can take evasive action. Ship surveillance is hindered by limited radar detection ranges. On the other hand, an aerostat-borne radar system has an extended detection range and a very long on-station time. Operational costs of some hundreds of dollars per hour for the sea-based aerostat compare it favorably with other methods of surveillance. The Coast Guard has demonstrated that deployment of an aerostat system is a cost-effective and efficient means of sea surveillance. With this system, a much greater area can be monitored, providing the potential for detecting a greater number of targets in a given period. The innovative MIST program, a new dimension in sea surveillance, is another good reason why the U.S. Coast Guard is semper paratus, always ready.